Hello students, in this video we'll see how to solve problem 5.6.103. Problem 5.6.103 asks us to solve the initial value problem, y double prime plus 2y prime plus y equals x squared, with the initial conditions that y of 0 is equal to 1 and y prime of 0 is equal to 2. So as we solve our homogeneous problem. The homogeneous problem is y double prime plus 2y prime plus y equals 0. The characteristic equation of which is r squared plus 2r plus 1 equals 0. R plus 1 quantity squared is how we factor that, equals 0. So we have a root r equals -1 with multiplicity 2. This tells us our homogeneous solution, y homogeneous, is c1 e to the negative x plus c2 x e to the negative x. Now we find our particular solution, y particular of x, will be, I have a quadratic expression on the right hand side, so look for a particular solution as a quadratic expression. A plus bx plus c x squared, and I'll find a, b, and c now. So y particular prime is b plus 2cx. Y particular double prime will be 2c. And now we'll plug it into the problem. So I have 2c, that's my y double prime, plus 2b plus 2cx, that's my 2 times y prime, plus my a plus bx plus c x squared has to be equal to x squared. So let's gather the like terms. I have a c x squared, that's the only term that has an x squared in it. I will have a b times x, so I have an x is multiplied by b, and over here the x is multiplied by 4c. And the constant term will be a plus 2b plus 2c. I'd like this to be equal to x squared. Now we can compare the coefficients. It's clear that those terms must match, so my c must be equal to 1. If my c is equal to 1, I would like this term to be equal to 0, because there's no x terms. So 4c plus b should be 0, which tells me that b plus 4 is 0, or b equals -4. And finally, I want that a plus 2b plus 2c equals 0, which tells me that a minus 8 plus 2 equals 0. That would be -6, so that tells me that a is equal to 6. So we have the solution of our problem. Y of x is c1 e to the negative x plus c2 x e to the negative x plus a, 6, bx, -4x, and c x squared plus x squared. This is the solution of our problem without the initial conditions plugged in. Now we'll plug in the initial conditions. When I plug in 0, I have to get 1. So let's plug in 0 to this expression. If we plug in 0, we have that 1 is equal to c1. This will be 0, this will be 0, and this will be 0, plus 6. So that tells me that c1 is equal to -5. And now I'll find c2 by looking at the derivative. So the derivative y prime of this will be -c1 e to the negative x plus c2 e to the negative x minus x e to the negative x minus 4 plus 2x. When I plug 0 into this expression, I have to get 2. So 2 has to be -c1. When I plug in 0 to this expression, I'm just going to get a c2 minus 4. We know that c1 is -5, so this is a +5. So this tells me that 2 is equal to +5 plus c2 minus 4, which tells me that c2 is equal to 1. Putting all this together, we can now write down the solution to our problem. The solution to our problem y will be c1 e to the negative x plus c2x e to the negative x plus 6 minus 4x plus x squared. And c1 we found to be negative 5, and c2 we found to be 1. So we can rewrite this as y equals c1, which is negative 5 e to the negative x, plus c2, which is 1, x e to the negative x, plus 6 minus 4x plus x squared. Here's our particular solution. Here's our homogeneous solution with the initial conditions plugged in, and we've therefore solved the problem. Thank you very much.